Okay, hi everyone. So today we are going to try something new. We have done our pre-PSPM or physics attack for college matriculation at Labour Matriculation College. So what I'm going to do is I'm going to take the paper just as how our students take the paper. I'll be setting myself 2 hours to finish the paper. So I will go through each of the question and try to solve it on the spot. At the same time, if there's some relevant concepts that are important, I will emphasize it in while discussing the question as well. Okay, so there's no answer schemes around me. I'll just solve it the way that all of the students solve it, just by seeing the question, trying to solve the question, just as how every student do it. So here's the timer. We will start now. Okay, so let's look at the first question. Okay, the first question asks us to check the dimensional homogeneity and provide the unit for the following formula. Okay, so then they say that this is the formula given: force times time equals to the final momentum minus initial momentum. Then they say that then they define everything over here, which is what we expect. Okay, so they ask for two things over here. The first thing is they ask us to to check the dimensional homogeneity. That means to check whether this equation here is homogeneous or not. Okay, so let's write something here. So if an equation is dimensionally homogeneous, okay, if equation is dimensionally homogeneous, I'm not solving a question, I'm just discussing a bit about the concept. So if it's homogeneous, right, what will happen is your dimension represented by square bracket, your dimension of ft here will be equals to the dimension of mv, and it should be equals also to the dimension of mu. Basically, all the terms inside this equation should share the same dimension, and if they share the same dimension, we can say that the equation is dimensionally homogeneous. Then that is considered a dimensional homogeneity check. Okay, so that's what we'll do for the first part of the question. And the second part of the question, they ask us to provide the unit. So if we are able to determine the dimension of these terms over here, then essentially we are actually nearly there to find the unit for each of these terms already. Okay, so let's first do the dimensional homogeneity check first. So I say if it's homogeneous, all these terms have to be having the same dimension. So we have to find the dimension of each of these terms one by one. We should not straightaway compare them. We should find the dimension of ft, find the dimension of mv, then find the dimension of mu. Then after we find all these three dimensions, if they happens to have the same dimension, then only we can say that this equation is dimensionally homogeneous. So that's what we will do. So let's find the dimension of ft. The dimension of ft is the dimension of f, square bracket, dimension of f multiplied by the dimension of time. Okay, so f we know is equals to ma. So if you want to take it slow, you can feel free to break it up into the dimension of mass times the dimension of acceleration multiplied by the dimension of time. So we know that mass, the dimension is big M. This is the dimension of mass m. This is physical quantity m. The dimension of physical quantity m is big M. Okay, this big M here is the dimension. It's a dimension of this physical quantity small m. Okay, so acceleration here is, we know it's ms negative 2, so it's length divided by time square. Okay, then you have your time, which is t. So if you multiply everything together, I believe we will get ml t negative 1. So that's the dimension of ft. Now we want to find the dimension of mv and mu. So mv is the dimension of mass multiplied by the dimension of velocity. So this one, mass, is just big M. Velocity we know is meter per second, so the dimension will be length divided by time. So if you multiply everything together, now you know that this is ml t negative 1. So it's the same as ft over here, so both of them have the same dimension. Now for the last term, let's try to find the dimension as well. So again, this is similar actually to mv, because this is just the initial velocity and final velocity. they are still velocity, so they should have the same dimension. So if you work out the dimension, I believe you get the same answer for all three terms. Okay, so because Ft is equals to mv, which is also equals to mu, therefore we can say that the equation is dimensionally homogeneous. Okay, so this is how we carry out a dimensional homogeneity test. We see how many terms are there, we find the dimension of all these terms, then if they are the same, it's dimensionally homogeneous. Okay, next thing, they ask us to provide the unit for the following formula. Well, actually the question a bit weird. They want the unit for Ft or for mv or what? What do you mean by unit for the following formula unit? I'll just give everything that I know. Okay, I know unit of Ft because it's ml t -1, m is mass SI unit is kg. Okay, length SI unit is meter, t is time, so this is s -1. So this is unit of Ft. The unit of mv is also the same, which is kg ms -1. And unit of mu is also kg ms -1. Okay, I'm not sure whether this is the way to do it or not. As I said just now, I don't have the answer scheme with me. I just do it like the way I see fit. Okay, so they asked me to provide a unit for the following formula. I don't know how they provide a unit for a formula, but I know each term can have their own unit. So I just give the unit for each term. Okay, so I think that's it. I finished solve question 1. That's about 6 minutes. Let's move on to the next question. Oh, that's not the end. Oh, there's 1b. Okay, I think we need to speed up a little. A force of 10 Newton acts at an origin in the direction of 40 degrees above the positive x-axis. So let's probably sketch the axis first. Only we are able to sketch out the situation. So we have our x and y axis. You have a force of 10 Newton, then it's 40 degrees above the positive x-axis. So 40 degrees above is over here, positive is this side, this is negative, so above positive is over here. So your 10 Newton should be around here. Let's call it F1. F1 is equals to 10 Newton and it's at an angle of 40 degrees above the positive x-axis. A second force of 8 Newton is acting at the origin in the direction of negative y-axis. Negative y-axis is pointing downward. So this one we call it as F2 maybe. So F2 is 8 Newton and it's pointing in the direction of negative y, so that's downward. So now they ask you to find the magnitude of the horizontal component and the vertical component of the resultant force. Oh, interesting. They ask for magnitude of the horizontal and vertical magnitude. I assume they only want the value. Probably they are not interested with the sign. Because if it's me, I'll probably ask find the horizontal and vertical component. Then I know this one I need to keep the sign. But they write magnitude, then I'm not sure whether I need to keep the sign or not. But never mind, I don't think they are so concerned with all these things. Let's just find the resultant force first. Okay, so what do? We have a diagram. What we do is we resolve it first. Okay, you resolve it into your x-axis f1x, which is equals to 10 cos 40 degree. Okay, then you have your fy. Your f1y is equals to 10 sine 40. Okay, once you're done with that, now we just sum out everything in the x component, everything in the y component. For x component, there's only one force, which is f1 cos 40. Okay, if you prefer to write it slow, probably we can write in greater detail. Then we can write it as f1 cos 40 degree. So you can proceed with your substitution, then cos 40. Then from there you are able to get, I didn't even remember to bring my calculator. So then cos 40 will be 7.66. So if you are more concerned with the sign, you can write down the sign because it's positive. 7.66, indicating that it's pointing to the right. The positive here indicates that it's pointing to the right. Okay, sum of Fy. Fy, you have how many forces? You have your Fy, you have your F1 Y component and also F2. So you need to add both these up, but then opposite direction. So F1 sine 40 degree is the one pointing upwards, minus by F2, which is pointing downward. So that will be 10 sine 40 pointing upward, 8 pointing downward. So if you calculate it, I believe you will get negative 1.57. Okay, I think I'll just stop here. I will not go purposely remove the negative sign because they ask for magnitude. I don't think they are that particular. Okay, I think they are just finding the horizontal and vertical component. I think that's what they're asking for. Okay, so I'll just leave it like this for now. Okay, I don't need to combine it because they're not asking for the resultant force. They're asking for the horizontal and vertical component only. Okay, so let's move on. Question 2. Your figure 1 shows a pathway of a bus. The bus is moving from A to B at a velocity of 8 meters per second for 2 seconds. So over here, you know that the velocity to go from A to B over here, it's 8 meters per second. And the time taken to travel from A to B is 2 seconds. Then you say that from B to C, the velocity is 5 meters per second. And it goes on for 4 seconds. So the duration from B to C is 4 seconds. And lastly, from C to D, the velocity from C to D is 9 meters per second. And it happens for a duration of 3 seconds. So that is what we have right now. I believe you see that these are velocity and time. So you know that if you take the velocity multiply by the time, and you get the distance. Okay, basically what they are saying here is that it's moving with constant velocity of 8 meters per second. So if it's constant velocity, you take the 8 meters per second multiply by 2, you get the distance from A to B. Because this 5 meters per second over here is also a constant velocity, you take 5 meters per second multiply by 4, you get the distance from B to C. And the same idea for C to D. Okay, so they ask for the distance of each pathway passed by the bus. So distance of each pathway, probably call it as D. D of AB. Okay, question 1. D of AB is taking V of AB multiplied by T of AB. Okay, we are assuming constant velocity. They didn't specifically write constant, but they only give you one value. They didn't say it's increasing, they didn't say it's decreasing, they just say 8 meters per second, they just say 5 meters per second, they just say 9 meters per second. So I think it's safe to assume that it's a constant velocity. So you can just move on and say that this is 8 times 2. So this will be 16 meters. Continue. Distance from B to C, we'll be taking the velocity of B to C times the duration from B to C. Again, this will be 5 times 4. This will be equals to 20 meters. And lastly, your distance from C to D is taking the velocity from C to D multiplied the duration from C to D. So that will be taking 9 multiplied by 3, that will be 27 meters. So I think that answers the first question, which is to find the distance of each pathway. They didn't ask me to sum it up, so I will not be summing it up. So let's do question 2. Question 2 asks for the displacement of the bus. Displacement actually means the shortest distance, or you can think of it as like the final position minus the initial position, right? So basically what we are finding here is we are finding the distance from here to here. To be more specific, this is the displacement. Okay, so but we know that displacement is actually just the summation of everything that happens along the way. Okay, if you sum them up, taking care of the direction, then the resultant displacement of AB plus BC plus CD, you will get the you get the resultant displacement. Okay, so that's what I'm going to do. Many people can have different methods to solve this problem. It's okay, nothing to worry about. Okay, what I'm going to do is I'm going to do it like this. Okay, so I've already labeled in the diagram, this is my displacement, right? Okay, so what I need to figure it out is the magnitude and the direction of the displacement, because displacement is a vector quantity. So for the magnitude, probably I need to use Pythagoras theorem. I need to find what is the distance from here to here, and I need to find the distance from here to here. Okay, so this is what I want to find. So if you look at the diagram, this is what I want to find. This is what I want to find. Okay, this one I think is quite straightforward. It's just a distance from B to C. So this one is 20 meter. This one is 20 meter. But for this one, it can get a bit tricky. We know that the whole distance here is 27 meter. And we know that just this single portion from A to B, from here to here, A to B, this portion here is 60 meter. So I think if you take 27 minus 16, you're able to get 11, and that's the distance over here. Okay, distance over here is 11 meter. So what I should write is I should write 27 minus 16 meter. Okay, so now I know the x component, I know the y component of displacement already. What I can do is just sum them up. So displacement is equals to sx squared plus sy squared, and sx we know that it's 20 square. The unit is right, the unit is meter, no problem. This one is 27 minus 16 square. So let's try to calculate it. 20 square plus 11 square. So that is 22.83 meter. Okay, so that's the magnitude of the displacement. We still have to find the direction of displacement as well. So the direction of displacement, tangent theta is equals to sy over sx. Okay, standard procedure to find the angle. When we say angle, is the angle over here. Okay, because angle always from the positive x-axis. No, I mean from the x-axis. Okay, so this one will be 27 minus 16 divided by 20 by doing tangent theta. Okay, so theta should be equals to tangent 28 degrees Celsius, 28 degree. Okay, so my final answer for displacement will be 22.83 meter, and it's 28.8 degree. This is below positive x-axis. Okay, how do I check the angle? I put a axis on my starting point. So this is above, below, negative, positive. So below positive x-axis. Okay, so that's my displacement. Let's move on to average speed and average velocity now. So average speed, as we know, is the total distance traveled divided by time, the duration for the total distance to be traveled. Okay, average speed is total distance traveled divided by time, or the duration. Okay, total distance traveled here is just taking DAB plus DBC plus DCD. So that one should be quite direct. Oops. DAB plus DBC plus DCD divided by the total duration for everything to happen. You can do it slowly by saying that this is TAB, plus TBC plus TCD. Okay, you can do it that way. So this will be 16 plus 20 plus 27 divided by the duration, which is 2 seconds plus 4 seconds plus 3 seconds. So if you calculate everything, you get 7 meters per second. Okay, so that's average speed. On average, it covers distance of 7 meters for every second that has passed. Okay, so average velocity, it's not the same thing as average speed. If you talk about average velocity, we are talking about displacement over time. Displacement over time. So we know that our displacement, the magnitude is 22.83, so you can put this as our displacement, and the time will be 2 plus 4 plus 3. I should write a line TAB plus TBC plus TCD, but never mind. Continue. 2.83 divided by 2 plus 4 plus 3, you get 2.54 meter per second. I think my camera is not working suddenly. Let me check what happened. Okay, I'll come back soon. Okay, I'm back. So let's start the timer back. Okay, so just now we managed to calculate everything already. So we have our average speed, we have our average velocity, everything seems fine. So let's move on to question 2B. Is everything working? Okay. 2B. Okay, in figure 2, a ball is thrown leftward. Okay, this is interesting. We seldom see ball being thrown leftward in our syllabus. It's usually to the right. Okay, never mind. Okay, thrown leftward from the left edge of the roof. So this is your building. This is the roof. Your ball is being thrown to the left at height of h above the ground. So this building here has a height of h. The ball hits the ground 1.5 seconds later. So I assume the ball will go from here to here within 1.5 seconds. Then the distance d is equals to 25 meters from the building. So this will be from here to here is 25 meters. So the displacement in the x direction will be negative 25 meters. Okay, and at an angle of 60 degrees with the horizontal. Okay, this 60 degrees where? The ball hits the ground 1.5 seconds later at a distance of 25 meters from the building at an angle of 60 degrees with the horizontal. Okay, so I think this 60 degree over here, it's for this hits the ground at an angle of 60 degrees with the horizontal. So probably I should label it more clearly. So I think they also give a bit of hint. The 60 is over here. Then the D over here is 25 meters. Then this whole journey here, the journey is from here to here, and it takes up 1.5 seconds. Okay, I think that's all the information that you have. Okay, so this is a projectile motion question. If you are my student, usually projectile question we will do in 5 steps, right? So let me list down the 5 steps. So first step, you visualize the situation. They provide a diagram already, so there's nothing much for us to draw. We just fill in the information into our diagram. The second part is to determine the initial and final position for every single question. Okay, as you can see, I haven't even started to read what is question 1, what is question 2. I'm just reading a situation and filling the information in my diagram. What I want to do now, later for step 2, is to read the question. Then for every question, I determine where's the initial and final position. Okay, then my third step will be to do my Survet table. And because this is a 2D motion, you need X component and Y component. Survet table, followed by finding the equation. Step 4 is pick equation. Then your step 5 will be to substitute and you get your answer. Okay, let's try to do it. visualize is done. Let's look at the first question to look at where is the initial and final position for that question. First question is find H. Find H. H is the height of the building. So for that, we can safely assume that we will need to pick an initial and final position, one at the top of the building, one at the same height as the bottom of the building. So for this question, we'll take this point over here as our initial. Initial for question 1, we'll pick it as here because that's the top of the building. Then here, which is the bottom of the building, we'll pick as the final position for question 1. Okay, because the y component of displacement will be equals to negative h later, and that's what we want to find. Okay, so we are done picking our initial and final position. Your next step will be to do your Sovet table. Okay, Sovet table over here for question 1, you need to do it for x component and you need to do it for y component. So sx, ux, vx, ax, t. So this is the Sovet table. You write out everything first, then you fill in the information. No matter you have the information or not, you write out everything first so that you are clear what you have, what you don't have. Okay. So Sx is the horizontal displacement from here, this point, initial point, to the final position. What is the horizontal displacement? So the horizontal displacement will be measured from here until here, which is this point over here. Okay, we see that the direction is to the left, so this will be negative. So it's a negative displacement. So for this one, we write it as negative 25.0 meter. Okay, that's D, right? Negative 25.0 meter. That's what we have for horizontal displacement. Next, initial velocity x. Initial, we don't have any information. We don't know the angle. We don't know it's launching at what angle. We don't have angle, we don't have velocity. So I think it's fair to say that we don't know much about ux. So we leave it blank first. But for Vx is something happening at the final position. At the final position, we do know the angle is 60 degrees, but you know that how should I explain it? The velocity vector at this point will be like this. This is what the velocity will look like, V final. And you know that the x component is just 60 degrees over here. Then you can break it into your Vy. I think it's a bit too complicated. Let me wipe off some stuff first. Again, this is the final position. Final for question 1. Okay, then the velocity is supposed to be at an angle something like this. Okay, where if you do your axis, this will also be 60. This is your velocity. So your Vx will be over here. Okay, so this one you can call it as V cos 60. But because it's pointing to the left, once again, this will be negative V cos 60 degree. Okay, for your acceleration in the x dimension, acceleration in the x component is 0 because this is projectile motion. You don't have acceleration in the x component, and because you don't have acceleration, you know that the velocity will not change in the x component. The initial velocity for x component will be the same for the final velocity for x component. So this one you can copy it back for the initial velocity x component. This one is the same thing because the velocity doesn't change in the x component. Okay, then the time we know that it's 1.50 seconds. Okay, move on to the y component. For the y component, how much is your displacement in the vertical direction? You go from initial to final, but looking at the vertical component only. So that will be measured from here to here. Okay, but we know that this is related to the height of the building, but we have to be very aware that this is going down. So this is negative direction as well. So for this one, we have to write it as negative h, not just h. It should be negative h because it's moving downwards. Okay, uy again, if because we don't have any information regarding the initial point, we don't have the angle, we don't have the initial velocity, so uy should be left empty. Vy, we know that it's pointing downward, and if you resolve the vector that I labeled here just now, if you resolve here, I believe the y component will be v sine 60, but negative sign because it's pointing downward. So this one will be negative v sine 60 degree, and your ay again is projectile motion, negative 9.81 meter per second squared. Okay, so now we have already listed down everything in our Subet table. Right now we have to pick the correct equation to solve the problem. Okay, to pick the correct equation to solve a problem, what is the question asking for? The question is asking for h. H is over here, so definitely we will be solving the question using the y component. Okay, let me show you how to select my equation. Okay, I know I want to find h, so definitely sy has to be in my equation, and I need to use all the information that I have. All the information that I have is ay, t, and also vy. Okay, I cannot cross into the x component because in the equation, if you do x, it's only x. If you do y, it's only y. So for now, I know that the thing that I want is in the y component. So I have to solve everything using information in y and also the time. We have 4 information here. So definitely our equation should have s, v, a, and t inside. Oh, but we don't have such an equation. We have only SUAT. SVAT. Okay, but what we know here is this is the unknown that we want to find, but there's also another unknown over here, and that another unknown is v. So in order to get h, right, probably the first step is to get v first. We need to get v first. Only we have the value over here, only we can consider how to find sy. So for now, we don't really have the value of v, we have to find v first. So probably we can find v in x dimension maybe. In the x dimension, we have symbol v over here. Let's try to figure out how to find it. Okay, for your x component, you want to find v. V is over here, but v can also be found in ux. You have value of sx, you have value of ax, you have value of time. Okay, so make sure your equation should have s, a, and t inside, and also either u or v inside in order to find v. Okay, so you want SUAT or SVAT, and I believe there's an equation for SUAT, and the equation will be Sx is equals to uxt plus half ax t squared. Okay, this equation has s, u, a, and t. That's what we want, s, u, a, and t. We have t, a, and s that we have information, and u contains the v that we want to find. Okay, so once you selected our equation, we can just proceed with our substitution. So substitution, negative 25.0 is equals to ux is negative v cos 60 degree times time, then plus half, ax is 0, so we know it will cancel out later. So this one will be 0. So now you are time, you have the time. What am I doing? We have the time, we need to substitute the time in. This will be 1.50 plus half ax is 0 times squared. Okay, so now I'll bring everything over to calculate v. So this one will be 0, of course. Okay, negative 25 divided by 1.50 divided by cos 60 degree, the sign. So it's 33.33333. Okay, so we call it as 100 over 3. Okay, I'm not writing it in decimal because this is not the final answer that I want. I still need to use it, so better keep it in fraction form. It's okay. Okay, so we get v right now, and v is the thing that we want to insert here. Okay, is it the right thing to do? VUAS S. We still have to use the time. So how should we solve it? so now this thing we have it already. So now we will have ux. Okay, so how to proceed with this question? S-U-A-T B squared U squared AS. I think no matter what, we really need the uy. How are you going to get the uy? So from this part over here, we know that ux is equals to negative 100 over 3 cos 60 degree. We know that Vx is also the same thing, so Vx is equals to ux is equals to negative 100 over 3 cos 60 degree. So that's what we have. But what now? I forgot very important information. What am I doing? Okay, you read the question carefully. It says that a ball is thrown leftward from the left edge of the roof. Leftward means by the ball will leave the roof in the left direction. So if it's leaving the roof in the left direction, that would means that your ball will be a horizontal projectile. It means by it's leaving like this. It is not leaving at an angle, it's not leaving downward like this, it's leaving out horizontally, then after that fall. So in that case, right, your uy should be equal to 0. Okay, I don't know whether I make it clear or not, because you're going leftward. If you're going leftward initially, you have no down, you only have downward component. You don't have you don't have any. No, this is what is this? thrown leftward, moving to the left, but now they are showing there's an angle. Why do they say leftward but there's an angle? Am I spending too much time on this question? If it's an exam, I should probably skip and move to the next question. Okay, I'll remove my uy is equal to 0 first, because even though I say uy is equal to 0, but obviously here uy is not equal to 0, there's a negative value. Okay, I should probably remove this one. Can't believe I'm stuck. What do I do now? This way. Yes. Okay, if you get V already, right? If you get V already, then you can put in this V inside here, right? Then you have the value for V. But okay, let me clear things up so that I can explain it properly. Okay, first of all, our aim is to find S. And in order to find S, we have to use information that we have. And information that we have will be AY and T. Okay, we want to find something in the Y component. We can only build an equation in Y component. So you have value of A and T. So you have to either use, you need 4 unknown. There's always 4 unknown in one equation. So you have 3 unknown. What's the 4th unknown? It can only be U. It cannot be V, because there's no equation with S, V, A, and T inside. There's only equation with S, U, A, and T inside. So definitely you will need the equation and you need uy as well. So you have to find uy first. That's your first step. That's what you need to find. Okay, let's label in green. I want to find UY. In order to find UY, I will need to use information regarding AY that I have, time that I have, UY that I want to find, and also VY. Okay, I need to use these four quantity over here to find UY. Okay. In order to find UY, I need to use equation with U, V, A, and T inside to find UY. Okay. But in order to do that, I need to find what is V first. Okay. So that means I have to find V first. So in order to find V, I need to go to the X dimension. So in order to find X dimension V is over here. So I need an equation that has SVAT or SUAT will do. Okay, because there's V inside the UX, right? Okay. So from here, this is my approach. Okay, so now I'm going to write down nicely. This is step 1. Step 1 will be to find my V. Okay, next step 2. Step 2 will be in green, right? Okay, step 2 is in green. Step 2, the purpose is to find UY. Okay, let me label clearly because I think this is quite a fun question. There's many layers. This one will be to find V. Okay, so now we find UY. Find UY, we need to use VY is equals to UY plus AY T. VY is negative 100 over 3 sine 60 equals to UY is what we don't know plus AY is negative 9.81, time is 1.50. So let's find UY. Yeah, I'm sorry, I didn't manage to figure out on first try. If you look at this video, it might be feeling very confusing. But this is exam, right? Okay. Okay, I get VY minus. Okay, so this is what I get for UY. Negative 43.58 meter per second. Let me double check. I got nervous. It's already 42 minutes already. Answer. Calculate wrongly. Negative 14.15. Let me double check it. I don't want to make a mistake at this point. Okay, seems right. Okay, so I get my UY already. My next step will be third step. Third step will be to find H. Okay, Okay, find h, that will be sy, so I need to use an equation as sy is equals to uyt, s is equals to ut plus half at square. So this one is negative h, this one is negative 14.15 times 1.50 plus half negative 9.81 1.50 square. Okay, calculate. Okay, so from here I get answer for h will be 32.27 meter. Okay, so that is the height of the building. Well, I think it's a very elaborate process. It's been a while I do a simple question that requires so many steps. I don't know how many marks will be contributed to this question, but never mind, that's not my part to think about. Focusing on solving the question now. Okay, next question. What are the magnitude and angle relative to the horizontal of the velocity at which the ball is thrown? Okay, they want the magnitude and angle, means by they want the magnitude and the direction relative to the horizontal. So means by later when you find the angle has to be from the horizontal. So this will be theta. Okay, it will be from this angle over here. Okay, at which the ball is thrown. So they are looking at the initial position over here. They want the angle over here. So that is initial. So we want ux, we want uy. I think we can find ux already because we have v. We also have uy. That's what we find in step 2. So we have ux and uy. We can find the magnitude, we can find the direction. I think that's no problem. Let's try to solve it. Question 2. ux is equals to negative v cos 60. We know that v is equals to negative 100 over 3 cos 60. Then uy is equals to negative 14.15 meter per second. Okay, 100 divided by 3 times cos 60. Negative 16.67. Okay, magnitude u is equals to square root of ux square plus uy square. So once again, square plus this is what I get, 21.86 meter per second. Let me double check once again. Okay, that's about right. Okay, so that's your magnitude. Now they want the angle. Again, do the same thing. Uy over ux. This is what we do in question 1b just now. So theta is equals to inverse tangent. Uy is negative 14.15. Ux is negative 16.67. Okay, calculate. Around 40 degree, I think. Okay, so we find our magnitude, we find our angle already. Probably it's nice that we keep everything tidy, write the final answer in vector form. Magnitude and direction. This is 40 degree below your negative x-axis. Again, why is it below negative x-axis? Try to sketch a axis over here. Then this section over here is below negative x-axis. Okay, so that's it. That's for question 2b. Wow, it's 1 hour, near 1 hour already. I should probably speed up a little. Let's move on to the next question. A tennis ball of mass 0.080 kg hits a wall at a speed of 32 meter per second and rebounds at a speed of 22 meter per second. So to illustrate the situation, we probably have a wall. Hits a wall, right? Okay, so you have a tennis ball. A tennis ball initially comes at a speed at 32 meter per second. Then it gets rebound. Okay, let's draw a dotted line to represent the rebounded tennis ball. Rebounded tennis ball is 22 meter per second. Then now they ask for the change in momentum of the ball. Well, I think that's quite direct. Okay, P. For me, I usually keep it more critical of the components. I write mvx minus mux. So I can factorize a mass. So that's vx minus ux. Okay, the mass is 0.080. I'm taking the positive direction as to the right, the negative direction as to the left. So based on this diagram, 22 is to the left, so there'll be negative 22 because that's a negative direction. Minus ux, I'm letting it going to the right, so that will be positive 32. Okay, so negative 22 minus 32. Times 0.080. Okay, negative 4.32 unit for momentum, mass times velocity, ms negative 1. Okay, double check. Okay, good. Okay, so this one, that means if I say it's negative, right, that means the momentum later. I should write change in momentum. Sorry, this is my bad. You would have to write change in momentum. This is change of momentum. If I'm writing it in vector, the magnitude is 4.23 kg ms negative 1. The direction is negative. Doesn't mean it's pointing to the left because I'm drawing this version here, but they didn't say the tennis ball is moving to the left or to the right. This is my imagination. It can be the ball moving from right to left, rebound towards the right. So there's many versions of it, but I know that the change in momentum is in the negative direction. And negative direction is opposite the direction of initial velocity. So I can write it as opposite the direction of initial velocity u. Okay, so if the initial velocity is pointing to the right, then the change in momentum will be to the left. Okay, if the initial velocity is pointing to the left, then the change of momentum will be to the right. Okay, this is a more general way of stating the direction. Next, determine the average force on the ball if the impact between the ball and the wall lasts for 0.15 seconds. They ask for average force. This one, I think you need to use your impulse momentum theorem. So impulse momentum theorem. Okay, why do I know it requires impulse momentum theorem? because I know that impulse is equal to change of momentum. Change in momentum, this one you get it from question 1 already. This one is what we want in question 2. Because impulse later, you can break it open to become average force multiplied by the duration of the impact, and is equals to the change of momentum. So for this situation, to find our average force, that will be taking change of momentum divided by the duration for the change of momentum to happen. So this one is, I can write negative 4.32. If you're being very careful about the component, you can write it as fx, fabx. This one is delta px, delta px. Okay, so negative 4.32 divided by 0.15, then divided by 0.15, you get negative 28.8 Newton. Okay, why do I add on the negative x over here? Is because if you have negative sign and positive sign, that indicates direction, right? You're actually calculating component. If there's positive 28 or negative 28, and the positive or negative indicates to the left or to the right, right? What you're calculating is component actually. So to be more formal, you have to have your x component or y component indicated. But actually, they also didn't say the tennis ball is going upward, downward, or leftward, rightward. So I don't think it's very important over here. So, but the important thing is you should write down your final answer. Your final answer is F is equals to 28.8 Newton. And again, once again, it's negative, so means by it's opposite the direction of U. But I don't think they will be so strict about this. As long as you get 28.8 or negative 28.8, I think they will accept the answer. And for the change of momentum also, even if you get negative 4.32 or you get positive 4.32, I think both should be accepted, okay, at our level. Okay, but to be more formal, you probably should state the direction. This is what I usually do. Okay, so done with question 3A. Next, question 3B. You see a system like this, probably you should think about this is regarding forces really. Okay, a mass M of 5 kg is suspended by a rope with negligible mass of length 2 meter. Okay, suspended by a rope with negligible from the ceiling as shown in figure 3. So it means that this is the rope from here to here to here. This is one piece of rope which is 2 meter. Then a force of 45 Newton in the horizontal direction is applied at the midpoint of the rope. So it means by this is 2 meter, this is 2 meter, right? At the 1 meter point, you are pulling the rope to the right with a force of 45 Newton. Okay? Then they ask what is the angle of the rope that makes with the vertical in equilibrium. Okay, so they ask if this whole system is in equilibrium, what should be the angle over here? Okay, if we want the whole system to be in equilibrium, what should be the angle over here? Again, if the whole system is in equilibrium, you should expect that the sum of fx is equal to 0, the sum of fy is also equal to 0. So that one is important. But before I do anything, we will follow the same 5 steps that I discussed in class usually. Let's go through the 5 steps. The first step will be to sketch the FBD. Then after you sketch your FBD, you resolve your FBD so that everything is on the x and y axis. Your third step will be to check whether the system is in equilibrium or not. Okay, if it's yes, in equilibrium, then you use sum of f is equals to 0. If it's not in equilibrium, then you use sum of f equals to ma. But you indicate the direction of A near the free body diagram. Okay, and the fourth step, you solve the equation. Okay, follow these 4 steps over here. First step, we sketch a free body diagram. First, use a dot here to represent the object of interest. I think for this case, we are very familiar already. Our object of interest will be this point over here. So this is our object of interest. Again, we sketch our axis based on the diagram. Then now we ask ourselves the 5 questions. The first question, does object has mass or not? This point R over here is a point on the string. And we say that the rope here is negligible mass. Therefore, this point P over here does not have any mass. And because this point P over here does not have any mass, we will say that this point P here, not point P, this point R here is massless, therefore no weight. So there should be no weight at point R. Point R, free body diagram, should have no weight because the point R here doesn't have mass, doesn't have weight. Okay, next, is point R here connected to any strings, ropes, or cable? Yes, it's connected to one string over here, it's connected to another string over here. A rope, sorry. One rope over here, another rope over here. So you should sketch tension, another one, tension. But again, this is two different sections of the string. So because they are on different section on the string, we should probably give them name. So this one you call it as T1, this one call it as T2. Okay, next question, is there any force explicitly stated in the diagram or in the question? Yes, they explicitly stated that there's an external force of 45 Newton acting on point R. So yes, there will be an external force. Okay, next, is the point R here in contact with any surface? No, it's not in contact with any surface, so no normal force. Fifth question, if it's in contact with a surface, is it a rough surface or a smooth surface? In this case, it's not in contact with any surface, therefore no roof, no smooth, no rough. We know that this is no friction as well. So this is a complete free body diagram, but we still need to label the angle. So now this is a complete free body diagram for point R. Let's also draw the free body diagram for mass M as well. For mass M, you use a dot to represent mass M. And now you sketch a free body diagram for mass M. You see that mass M here has mass. Therefore, mass M here will experience a gravitational pull by the Earth. Therefore, it has weight. Next question, is mass M here connected to any strings, ropes, or cable? Yes, it's connected to one rope over here. So there will be tension. And because this section of the rope is the same as this section of the rope, so T2 here will be the same as this T2 over here. Okay, they are both the same section of the rope, so they should share the same tension. Okay, I believe you can see clearly that there's no external force, there's no surface in contact, no normal force, no friction. So this is the free body diagram for mass M. So now once we are done, we should make sure that everything is in equilibrium or not in equilibrium. They say that the system is in equilibrium already. So now we will use sum of F equals to 0. Okay, so let's do it slowly, starting from mass M first. For mass M, I know that sum of F, there's only Y only, there's no X. Okay, I mean there's no X component over here with forces, there's only Y component with forces, so sum of Fy is equal to 0. That will be T2 minus weight, which is equal to 0. So T2 will be equals to the weight. Okay, weight is equals to mg, and that will be 5 kg times 9.81. Okay, let's just keep it like that. Later on, you calculate it. Next, for point R, we know that it's also in equilibrium. So for point R over here, I should expect sum of fx to be equal to 0, sum of fy to also be equal to 0. Okay, but before we do anything, we should probably resolve it. I forgot there's step 2 over here that I need to resolve. Let's resolve it. Break it open. So this one will be T1 sine theta. Based on this theta over here, this is T1 cos theta. So now if we know that, we can do our equation. For x, there's 1 to the left, 1 to the right. So we can say this is T1 sine theta minus f is equals to 0. For y, there's one force pointing upwards, one force pointing downward. So this will be T1 cos theta minus T2 equals to 0. Okay, so now T1 sine theta is equals to f, and f is equals to 45. So T1 sine theta is equals to 45. Next, T1 cos theta is equals to T2. We know that T2 is equals to 5 times 9.81. This is T1 cos theta. Okay, again, what is the question asking for? They're asking for angle. So you want to find angle, we are not interested to find T1. So we should probably find a way to cancel out T1. Okay, we know they want to find angle, we want to cancel out T1, so probably we can take this equation, divide by this equation. Then if you take this side, divide by this side, the T1 can cancel each other out, then you're left with sine divided by cos, then there will be tangent. So that's a way to go. Let's try to do that. So T1 sine theta is equals to 45 divided by T1 cos theta is equals to 5 times 9.81. So now we know that T1 will cancel each other out. Sine divided by cos is just tangent theta, which is equals to 45 divided by 49.05. Okay, so now you can find the angle by doing an inverse tangent on this problem. Okay, what will we get? $42.53. Okay, so that's the answer. They are looking for the angle only, right? They're not asking for direction, so that is the angle that it makes with the vertical. So this value here is 42.53. In order for the whole system to be in equilibrium, where the sum of fx, sum of fy are all equal to 0. Nothing is moving, everything is at rest. So the net force for x and y should all be equal to 0. Okay, we're done with this question. Let's move on to the next one. Next one, you have a parcel of mass 2 kg placed on a rough inclined plane. So probably we can label this surface here is rough. Okay, it is released from rest. So from rest, we should probably say u is equal to 0 meter per second and accelerate at a constant rate of 4 meter per second. So from here going downward, a will be equals to 4 meter per second square. Okay, determine the coefficient of kinetic friction. This is Fk for the parcel. Okay, this is still question 3, so this is still chapter 3. So again, we're going to follow through the 5 steps like just now. So if we follow through the 5 steps like just now, what we are going to do, we are going to start with free body diagram. So this dot here represents this parcel over here. And for our axis, we'll put one axis parallel to the inclined plane, one axis perpendicular to the inclined plane. Okay, one of the axes is here, another axis is here. So we ask ourselves 5 questions. Does the parcel have mass or not? Yes, it has mass, therefore it is experiencing weight. Next question, is the mass connected to any strings, ropes or cable? Not connected, therefore no tension. Third question, is there any forces explicitly mentioned in the question or in the diagram? Well, if you read through the question, you look at the diagram, I believe they didn't mention any new forces, any external forces, nothing being mentioned. Question 4, is the parcel here in contact with any surface or not? Yes, it is in contact with the rough inclined plane. So because it's in contact, there will be a normal force. Normal force should always be perpendicular to the surface. So perpendicular to the surface is this direction, up or down. Remember, normal force always push. So the surface will push on the parcel. Push on the parcel, so it should be in that direction. And because it's perpendicular to the surface, we know that this should be along the y-axis. Okay, so this is a normal force. Lastly, kinetic friction. They already mentioned it's kinetic friction already, so we don't have to go think about whether it's static or kinetic. Plus the object is already moving. If it's sliding across the inclined plane, we know it's kinetic friction already. Okay, so kinetic friction, we know it's opposite the direction of sliding. So where's the direction of sliding? We know it's sliding down, right? Okay, accelerate this way. Okay, we already see an arrow, it accelerates this way. If it accelerates this way, then we know that the friction should be in the opposite direction because friction opposes the direction of sliding. So therefore, your kinetic friction is this way. Okay, so we will ask ourselves 5 questions already. So this is our free body diagram. But of course, we need to put an angle for this value. So 30 is over there, we change it to 30 over here. Okay, done with step 1. Step 1 FBD done. Second step will be to resolve. So right now we want to resolve the free body diagram. So what force need to be resolved? we need to resolve the weight because that's the only force not on the axis. So this one will be weight cos theta. This one will be weight sine theta. Okay, now that we are done, we ask ourselves whether the system is in equilibrium or not. For x-axis, which is this axis over here, this is x-axis, we know that the object is sliding down and is accelerating at a constant rate. Accelerating means right, there's net force already. If there's net force already, means right, it is not in equilibrium. So for x component, it is not in equilibrium. So not in equilibrium, we have to indicate the direction of acceleration. So we indicate the direction of acceleration properly. We know it's going downward, sliding downward. So this is our acceleration direction. Okay. Next for y component. Y component is this component. We know that our block over here is not flying away from the inclined plane. It is not entering the inclined plane. It is moving along on the surface of the inclined plane. So it's not moving up, it's not moving down with respect to the surface of the inclined plane. So this means that it is at rest in the y dimension. So it is in equilibrium in the y dimension. Okay, so now we know that we are going to analyze sum of fx using equals to max because it's not in equilibrium. Whereas for y, we are going to analyze it equals to 0 because it's in equilibrium. So sum of fx is equals to max. Sum of fx consists of taking the force in the direction of acceleration minus the force opposite the direction of acceleration. Again, if it's sum of f equals to ma, right, the sum of f, take the force in the same direction as the acceleration minus the force opposite the direction of acceleration. Okay, so that would be w sine theta minus fk equals to max. Okay, so we can further open it up. This will be mg sine theta. And we know that we want to find mu k, right? Coefficient of kinetic friction. Coefficient means that you want mu k. So you have to break this open to become mu k times n max. Okay, let's try to do it for sum of fy. Sum of fy is equal to 0 because it's in equilibrium. So that would be n minus weight cos theta. Okay, so from here we know that normal force is equals to mg cos theta. Okay, so we want this value. This is the value of interest. We have the mass, we have g, we have theta, no problem. We have mass also, we have acceleration also. What we don't know right now is the normal, but normal can be found in the y-axis. So that means you have everything you need, you just need to substitute right now. Okay, so let's substitute. Mg sine theta is minus mu k mg cos theta is equals to max. Oh, we notice that all of them have mass, so we can probably cancel the mass. And now you can move around your subject. Mu k g cos theta is our subject. The rest to the other side. G sine theta minus ax. Alright. Okay, continue. Mu k will be equals to g sine theta minus ax, x component of acceleration, divide by g cos theta. Okay, so now we have everything. 9.81 sine 30 degree minus the acceleration rate is 4.0 divided by 9.81 cos 30. Okay, so we substituted in everything, just calculate only. Okay, so we get 0.1065. Okay, so this is the coefficient of kinetic friction. What's the unit? There's no unit for this coefficient. Okay, so that's it for question 3b2. Let's move on to the next one. Question 4. Question 4 shows a block of mass 60 kg pulled by a constant force. So this F here is a constant force of 200 Newton and it's pulling on a rough surface. So you should expect that the block is moving to this direction and probably there will be a friction in the opposite direction of sliding. This constant force causes the block to move to the right. Therefore, the sliding is to the right. The kinetic friction will be opposite the direction of sliding. Therefore, it should be pointing to the left. So that's what we should expect lah. Okay. They asked us to determine the net work done on the block. Okay. Oh, a bit tired actually. Net work done is work total. Work total can be found in different way. First, you can find the work done by force number 1 plus the work done by force number 2 plus the work done by force number 3. You add them on one by one, slow. Or you can find the work total by first finding the net force first. Then after that, you do net force cos Fs cos theta. Okay, or lastly, you can find the total work done by equate it to the change in kinetic energy using the work energy theorem. Okay, for this case, I don't think it requires work energy theorem because we don't know the speed. If we don't know the speed, then we don't know the kinetic energy, then we cannot relate to the kinetic energy over here. So it's one of these two methods. Both methods should do fine. Both methods should get the same answer. So I'll do the first method maybe. Okay, if I want to do the first method, I have to determine what are force 1, force 2, and force 3, right? So what I need to do now is sketch a free body diagram as usual. Again, this dot here represents the mass, 60 kg mass. Then it has an axis like this. Ask ourselves the first question. Does the block has mass or not? Yes, therefore it has weight. Next, does the block is the block connected to any strings, ropes, or cable? You see no strings, no ropes. This is not a rope, I think. This is just external force. So there's no tension for now. Next, is there any force being explicitly mentioned in the diagram or in the question? Yes, this F over here is an external force. F external. So this one is 47 degree. Next, is there any contact surface or not? Yes, there's one contact surface over here. So we should expect normal force pointing upward. Okay, lastly, is there any rough surface for the surface in contact? Yes, it's a rough surface. It's mentioned in the question already. So your direction of friction will be opposite the direction of sliding. Okay, so your friction should be over here. And this is kinetic friction. Okay, so now once we have everything ready, we will find the work done for every single force. That means that if you want to find work total, you have to find work done by normal, work done by weight or gravity, work done by the friction, kinetic, plus work done by the external force. Okay, luckily what happened is we know that the displacement is moving 50 meter horizontally. We know that the displacement will be following a direction of external force for 50 meter. So in that case, if you calculate the work done for normal force and work done for weight should be all equals to 0 because the theta is equal to 90. Therefore, your cos 90 will be equals to 0. Okay, so therefore we know that weight of normal should be equals to 0. Weight of normal, what am I doing? I'm not in a good state already. Work done by normal force is equals to 0. Work done by gravity is equals to 0. Both of these equals to 0. We just need to find the work done by the friction and also the work done by the external force. Very simple. Again, this is just Fs cos theta, but this theta is for kinetic friction, plus Fs cos theta, but this theta is for the external force. So now you can just key in everything. When we put in the force, when we put in the displacement, we just put in the magnitude. We let the angle behind to decide whether it's positive or negative work done. For the force, for the displacement, we just sub in the magnitude only. So this will be, the friction is 70 Newton, the displacement is 50, and because we know that the friction and the displacement are in opposite direction, we know the angle between them is 180 degree. Okay, next, your external force is mentioned to be 200, displacement is again 50, 200, 50. Okay, so this is your external force, this is your displacement. External force, displacement, the angle between them is 47 degree. So that will be your cos 47 degree. Okay, so if you combine them, I believe you get negative 3500 first, then you get you get 6819.98. Okay, so if you add them all up, you get 3319.98 joule. Okay, so this is the net work done. Okay, of course you can use other method to solve this problem. You can find sum of fx first, and you can find sum of fy. Then afterward, you find the sum of f using Pythagoras theorem. You find also the angle. If you have angle, then after that you do sum of fs cos theta to find work total. Okay, that's method 2 over here. Okay, but I'm not going to discuss it further. I'm a bit short of time. As you can see, 1 hour 20 minutes already. I'm still in question 4. I have only finished half of the paper only. Okay, next question. Question B. Question B over here, you have a sphere of mass 4 kg initially at rest. So let's label it. Initially at rest, 0 meter per second. Slides along a smooth and curvy surface. So this is the smooth and curvy surface. Why do they tell you smooth? Because it's frictionless. Because it's frictionless, only you know that your mechanical energy is conserved. Okay, now what are the question asking for? They ask for the potential energy of the sphere at point A. Point A, what is the potential energy? Okay, I think this one is a very straightforward question. You just find mgh, right? So your mass is 4 kg, g is 9.81, the height at A is 40 meter. So from this calculation, I believe you can get 1569.6 joule. Okay, potential energy, the unit is joule. So that's question A. Okay, question 1. Question 2. Question 2 asks for the speed of the sphere as it passes point B. So you're interested about information at point B. You have information regarding point A. So what you can do is you can equate the mechanical energy at point A and point B. Because you know that mechanical energy is conserved, mechanical energy won't change. If mechanical energy won't change, the mechanical energy at A should be equal to the mechanical energy at B. So that's what we are going to do. We equate the mechanical energy at position A to be equal to the mechanical energy at position B. Mechanical energy consists of kinetic energy and also potential energy. Okay, so this one again, that's KB plus UB. If you break it open, kinetic energy is half mv squared, but this is the velocity at point A, plus mgh. This is the height at point A. Then you have half mv squared. This is the velocity at point B. Then you have mgh. This is the height at point B. Okay, so now we have everything already. We can put in our value. But before we put in our value, we can probably see that all these terms here has mass. Because all these terms here has mass, we can cross out the mass over here. Okay, so now we can slightly simplify our equation. Our equation is now half VA squared plus GHA equals to half VB squared plus GHB. Okay, now we have all this ready. Let's do substitution. At position A, the speed is 0 meter per second. So that's what we are going to substitute for VA. Half 0 square plus G is 9.81. What is the height at A? at A, your height is 40 meters, so that's what you put in for height at A. Next, half VB. V is what we want to find. That's the question asking for. Then height at point B is 20 meter. Okay, so put in all the information that you know. And if you do your calculation, I believe you get VB is equals to 19.8 meter per second. Okay, so using conservation of mechanical energy, we are able to find the speed when the ball is at position B. Is it an X component speed or Y component speed? No, it's the combined. I mean, it's the resultant speed at point B. It's not X component, it's not Y component. It's just the speed at point B. Okay, we're done in this question. Let's move on. Oh, I need a break. Question 5. You have a 0.2 kg ball. Attached to the end of a string and is rotated in the horizontal circle of radius 1.5 meter on a frictionless table surface. Okay. So you have a frictionless table surface. You have a 0.2 kg ball attached to one end of a string, while another end of the string is whole. Then you go through a horizontal circular motion. To give an example. What kind of example? So let's say this is my board. This is my ball, right? Okay, let's get the ball. Okay, this is your board. Okay, then this is your table surface, frictionless table surface. This is your 0.2 kg ball. It's attached to the end of a string. So you imagine it is attached to a string, then it's rotated in the horizontal circle. This is a horizontal circle of radius 1.5 meter. Okay, then they say the string will snap when the tension exceeds 50 Newton. It's by your force, your tension in the string, if it's more than 50, it will snap. Then the string will cut off. Then after that, your ball will not be moving its horizontal circle. So now they ask what is the maximum speed. Okay, let's visualize the situation. You have your table surface. You have your ball. Your ball is connected to a string. The string is pinned on one place. After that, your ball will trace out a circular motion. You know that this string over here, it will trace out a radius of 1.5 meter. This is a 0.2 kg ball. Then T maximum is 50 Newton. Okay, this is chapter 5. Chapter 5 circular motion. You know that for circular motion, you have to sketch a free body diagram for the object moving in circular motion. The object moving in circular motion is the ball. So let's draw a free body diagram. Your free body diagram, your ball has mass, therefore it has weight. Your ball is attached to a string and the string is pulling you to the right, so that's tension. Is there any force being explicitly stated in the question? No. Is the ball touching any surface? Yes, it's touching the frictionless table surface, and that will cause the normal force to be pointing up. Okay, then they say it's a frictionless table surface, so there will not be any static friction or kinetic friction. So now this is a free body diagram. We know that the net force will be here, and this will be the direction of our centripetal acceleration. Okay, our centripetal acceleration is always pointing towards the center of the circle. Okay, and that's also the direction of the centripetal force. And centripetal force is actually just a fancy name for net force. So we can see here, for the x dimension, the net force is the tension. So this tension here will be the centripetal force. Okay, so you can say that FC is equals to tension. Okay, because this is the net force in the x dimension. You are moving in circular motion in the x dimension, not the y dimension. So the net force in the x dimension will be your centripetal force. Okay, so now we know this already. We know that sum of Fx is equals to MA. Okay, let's call it MAC because it's centripetal motion, circular motion, sorry. So this one will be equals to FC. So FC is equals to MAC. We know FC is tension. The centripetal acceleration, we can open it up to become V squared over R. So now we break out everything already. You can substitute. 50 is T max. Okay, so let's label this as T max. Let's label this as maximum speed. So 50, mass is 0.2, V max square over here. The radius of a circle is 1.5. Okay, everything is in. We just need to find V max. So from the calculation, I believe we will get 19.36 meter per second. Okay, again, your step 1 should be to draw a free body diagram. Then after that, you determine what is your centripetal force. Then you have to read the question, then solve the question. Okay. But as usual, free body diagram is essential. You should draw a free body diagram first in order to know what is the centripetal force. Centripetal force, again, just want to emphasize, it's not a new kind of force. It's just the net force in that particular dimension where the circular motion is happening. If your circular motion is happening here, then your net force in this left-right direction will be your centripetal force. If your object is moving in this direction, then the net force in this up-down direction over here will be your centripetal force. Okay, it's just the net force that is pointing towards the center of the circular path. Okay, so that's it for question 5. Let's move on to question 6. Question 6, you have figure 7. Figure 7 shows a graph of two waves. So you have wave A and you have wave B traveling to the right at the same speed. So both of these are progressive wave. Okay, I want to emphasize, okay, this one probably need to discuss a bit. Chapter 7, right, is a big chapter. This is chapter 7, oscillation and wave. So in this chapter, right, there's actually 3 types of things. We can probably extend until 4. 4 types of things that we study. First, we study simple harmonic motion. Then we study progressive wave. And then we study standing wave. Lastly, we study Doppler effect. So it's important that we look at the question. Every time we look at the question, we have to figure out what type of knowledge or what type of oscillation or wave is this. Okay, in this situation here, you can see that you have graph of two waves. So you know this is definitely not simple harmonic motion anymore. Okay, it's just progressive wave or standing wave. But you see it's traveling to the right. So traveling to the right means by this is a progressive wave. Because if it's traveling, then it has to be progressive. It has to be stationary, only it is a standing wave. Okay, so now we know that this we are using knowledge from progressive wave. Okay, so it shows a graph of two waves traveling to the right. Both wave A and wave B are now traveling to the right, and they are traveling at the same speed of 12 meters per second. Now they ask you to determine the wavelength, determine the frequency, and determine the maximum speed. Okay, let's look at the graph over here. This is a displacement distance graph. Displacement distance graph. So what you can get here is, from here, the y-axis will let you know this is wave A, right? This will let you know the amplitude of wave A. The amplitude over here will show you the amplitude of wave B. Okay, next thing, for one complete cycle of wave, one complete cycle over here, this is distance. So distance means by this is not time, this is not period. This will be wavelength of wave A. So for B, you can measure from here until here. This will be wavelength for B. Okay, always check your axis over here. If it's time, right? If it's time, then one complete oscillation, that will be period. If it's distance, then one complete oscillation, that one complete wave cycle, that will be wavelength. Okay, so in this case, this is wavelength, not period. Are we okay? So if we are okay already, then we can proceed to solve the problem. They ask for wavelength first, so we have the answer. We just need to read it. So for wave A, the wavelength is 2 meter. For wave B, the wavelength is 4 meter. So let's write it down. Question 1. Wavelength for wave A is 2.0 meter. Wavelength for wave B is 4.0 meter. Next, they ask for the frequency. How do you relate frequency with wavelength that we calculate just now? Well, we know that V is equals to F lambda, right? You have your speed of your wave already. You have your lambda, so what you can figure out is the frequency. Okay, so let's go. Frequency of wave A is equals to velocity divided by wavelength A. So that will be 12 divided by 2.0, that will be 6 Hertz. Next, frequency for wave B is just speed divided by wavelength of B. So this is 12 divided by 4.0, so that will be 3 Hertz. Okay, so done with frequency. Next, maximum speed. Maximum speed is Vmax. Vmax, the equation will be equals to A omega. Okay, so Vmax for A, of course you use amplitude for A and omega for A, right? Amplitude of A is 0.50, refer to the graph above. Then angular frequency is 2 pi frequency of A. So this one will be 0.50 times 2 pi. Frequency of A is 6 Hertz. Okay, you need to find the answer. Vmax for B, of course, again is A omega for wave B. Your amplitude for wave B is 0.25 from the graph above. Okay, over here, 0.25 is amplitude for wave B, 0.50 is amplitude for wave A. So done, 2 pi F frequency of B. So 0.25 times 2 pi times 3. Okay, so from this process over here, I believe you get 6 pi meter per second. This one you will get 1.5 pi, I think. Not 1.5, sorry. 4, half of 3. Yes, 1.5. 1.5 pi meter per second. If you are worried that they might not accept answer in pi, please expand it. Then you will get 18.85 meter per second for Vmax A, 4.71 meter per second for wave B. Okay, so that's solve question 1, question 2, and question 3. Okay, done. Okay, so this is question 6a. Let's move to question 6b. Question 6b, you have a 6 cm guitar string under a tension of 50 Newton. Always see if you have a guitar string under tension, right, you need to find speed somehow. Okay, because later they give you something about the mass. I think we do too many questions that we sort of can predict the pattern already. So this is a 60 cm guitar string. Let's probably just sketch it right now. This is your guitar string. It's fixed on 2N most probably. This is 60 cm. 0.600 meter. Let's convert it to SI. Then tension here it's 50 Newton. This is SI unit already, no problem. Mass per unit length is 0.1 gram per cm. This one you have to convert. Okay, every time you see things not in SI unit, right, it's better to just convert it. So mass per unit length here is 0.100 gram per cm. So if you convert, that one you take 0.100 gram per 1 cm. You want to eliminate gram, introduce kg. You want to eliminate cm, introduce meter. So 1 kg consists of 1000 gram, 1 meter consists of 100 cm. So if you do that, you get 0.01 kg per meter. Okay, so this is your mass per unit length for now. Okay, now they ask you to determine the highest resonance frequency that the string can be heard by a person. Determine the highest resonance frequency of the string that can be heard by a person that able to hear frequency up to 20,000 hertz. Means by that person, right, maximum can listen up to 20,000 hertz. So they ask if that person can listen up to 20,000 hertz, what's the highest resonance frequency that they can hear and that the person can hear. Okay, so that's what we're going to find. Again, you see M over L and you see tension, right? I think you cannot escape. You will have to find the speed somehow. Okay, so T over mu, tension over mass per unit length. Oh, for this equation, make sure you use SI unit now. Yeah, or else later you don't know whether it's cm or it's meter. It can be very confusing. Okay, so your tension is 50. Your mass per unit length is 0.01. So through this calculation over here, you get the speed of the wave traveling in the guitar string to be 70.7. Okay, now you know this is a stretched string situation and they ask for frequency. So you know that the frequency is equals to stretched string is NV over 2L. But now they ask for the highest resonance frequency and you know that the highest is 20,000. So you know that frequency must be less than or equals to 20,000 hertz. Therefore, your NV over 2L must be less than 20,000. Okay, you know you want to find N over here. You have your 70.7 from just now. And your length of your string is 0.600. So from here, you're able to find what is the highest harmonic number that you can go. Okay, you know that the speed of the wave in the string is 70.7, and you know that the string is having a length of 0.600. Under these circumstances, what is the highest harmonic number you can go without going over 20,000? That's what we are calculating here. Okay, so take 20,000 times 2 times 0.600 divided by 70.0. Okay, so you get your n to be less than 339.41, and because you know that n for stretch string n is equals to 1, 2, 3, 4 and so on. It must be an integer. So because it must be an integer, then the highest n that you can go without having frequency going over 20,000 will be 339. Okay, cannot take 340 because take 340, your frequency that you need will be larger than 20,000 already. So you have to get 339 so that your frequency will be 199 something like that. Okay, if you take 340, you find that your frequency that you produce is higher than 20,000. If it's higher than 20,000, then the person that we are seeing just now is not able to listen to this sound produced. Okay, so this should be the harmonic number, but they are not asking for the highest harmonic number. They are asking for the highest resonance frequency. So you have to go find this frequency. So how do you find this frequency? Well, frequency is equals to NV over 2L for stretch string, right? So now you're finding frequency max. So this one will be your harmonic number max. So this one will be 339. Your speed will be 70.7 divided by 2. Then the length of your stretch string is 0.600. So from this exercise here, you are able to find our maximum frequency to be 19975.7 Hz. Okay, so this is the maximum frequency, and now it's raining heavily. I don't know whether you can listen to me or not. So I'll put the timer on pause, and once the okay, and the rain is not so heavy right now. Let's continue. Can we? We can. Okay. Can we? Let's pause for a while. Okay. When the rain subsides, then we continue. Okay, let's continue. Okay, when the metal pipe is cut into two pieces, the lowest resonance frequency, okay, lowest resonance frequency means by its fundamental frequency. Let's probably jot it down first. Okay, the fundamental frequency in one piece is 256 Hz, and for the other is 440 Hz. Okay, so initially you have one piece of metal pipe. Then this metal pipe is cut into two pieces. They didn't tell us they cut into equal length or what, so probably it's safe to assume that they will not be the same length. Okay, then after cut, then this one piece over here, the fundamental frequency for this one piece here is 256, whereas the fundamental frequency for another piece over here will be 440 Hz. And now it asks us to determine the length of the original pipe. So later we will need to, let's call this as A, let's call it as B. So when we find the length of original pipe later, we will need to find the length of A plus the length of B, then you'll get the length of original pipe. Let's call it as L. Okay, so we have to find LA, we have to find LB separately first. Okay, you know that this is an open pipe. Okay, because it's a metal pipe being cut into two pieces, they didn't tell us they close any one end of it. So it's safely, we can assume that it's an open pipe situation. So if it's an open pipe situation, then you know that Fn is equals to Nv over 2L for open pipe. Okay, so we are looking at fundamental, so this one will be F1. But for pipe A, then this will be 1 V over 2 LA. Okay, I'm not labeling VA or VB over here. V, I'm just writing it as V because for both pipe A and pipe B, right, the medium that the standing wave is happening in is the air. Okay, the standing wave is happening in the air. So therefore, right, the progressive wave that is traveling is still in the same medium, which is the air. So if the two pipe, they share the same medium for which the wave travel, they will have the same speed. Okay, the speed of the wave depends on the medium in which the progressive wave is traveling. Okay, so because they share the same medium for both pipe, they should have the same speed of the wave. Okay, so now this one we can substitute. 1 speed of sound in air, 343. 2 the length of pipe A, LA. Okay, so first for pipe A, the fundamental frequency is 256. So from here, you can find the length of pipe A to be equals to 0.6699. Okay, let's leave a few more decimal places because later we need to add them up, right? This is still intermediate step. We still have to take LA, L of LB. So let's leave a few more decimal places. I think that's fine. Okay, let's move on to pipe B. F1 B will be equals to, again, this is fundamental. So 1 share the same medium. Don't need to separate VA or VB. 2 the length of B. So this one will be 440 is equals to 1343 to the length of B. So from here you can find the length of pipe B equals to 0.7795. Okay, so what we need to do now is just to add them up. Okay, let's move it slightly to the side. Total length is length A plus length B. So you get back the original length by adding up the length of two pipes. So right now the first one is 0.6699 plus 0.7795. Okay, so let's add them up. Okay, so I'll get here 1.45. Okay, 1.45 meter. Okay, so now I've obtained my answer for the original length. What I need to do now is to do the second question. The second question asks me to find the fundamental frequency that would have been produced by the original length of the pipe. That means by, if this is the original length of the pipe, which is 1.45, then what would be the fundamental frequency? The fundamental frequency, again, this is an open pipe, so this one will be 1V over 2L. So it's just substitution right now. 1343. 2, the original length is 1.45. So take 343 divided by 2. Okay, so my fundamental frequency will be equals to 118.3 Hertz. Okay, so this is question 2. Okay, so as you can see, if we connect back these two pipe, I mean pipe A and pipe B, you connect them back, you'll notice that the pipe is longer, right? So the pipe is longer, definitely the frequency will drop. Okay, the shorter the pipe, the shorter the pipe, the higher the frequency. Okay. Let me double check something. Yeah, that's why it doesn't make sense. Okay, I noticed that something didn't make sense here, so I checked my answer, and yeah, it turns out my answer is wrong. As you can see here, right, this is a lower frequency, this is a higher frequency. For higher frequency, your pipe should be shorter. For lower frequency, your pipe should be longer. We did an experiment in class where we blow on different type of pipes, right? Shorter pipes, higher frequency, longer pipes, lower frequency. So this is a lower frequency, so this pipe should be longer. This is a higher frequency, so this pipe should be shorter. But it appears that this pipe is even shorter than this pipe, so something is wrong. So I double check my answer, and it turns out that I did make a calculation mistake. Okay, so this one is definitely not 0.7795, so this one is wrong as well. So this one is wrong, so this one is wrong, so this one is wrong. Okay, so if you keep some conceptual understanding, then it will help you to sense whether your answer is correct or not. Like just now, based on my understanding, I know that shorter pipe should have higher frequency, but this shorter pipe, this is higher frequency, but the pipe is longer, so you know something is wrong over here. Okay, so I did my recalculation, and it appears that the answer is actually 0.3898. Okay, let me double check the other one as well. 0.6699. Okay, so add on with 343 divided by 440, that divide by 2. So from here I get 1.06. Okay, 1.06, then 343 divided by 2 times. Okay, so I get 161.8 Hertz. Okay. Okay, so this is my answer. So let's check whether the relationship is correct or not. This is the longest pipe. This is the longest pipe. Definitely the frequency should be lower than the other two original length of pipe B. Let me write it again. This is the longest pipe, so it should have a lower frequency compared to pipe A and pipe B. So 256 and 440 is larger than 161, so it makes sense. Next, 256 and 440. 440 is a higher number, higher frequency, shorter pipe. So you see this pipe is shorter than pipe A. Pipe B is shorter than pipe A. So everything seems to make sense. So we can move on to the next question. Okay, question 7. A thin light wire of 75 cm long have a circular cross-section of 0.55 in diameter. Okay, let's write down all the information we have first. So this one you attach weight, right? Attach weight means by it's vertically arranged. So you have a thin light wire. This thin wire has 75 cm long, 0.75 meter. Then it has a circular cross section of 0.55 in diameter. So the diameter from here to here is 0.55 millimeter. Change it to meter times 10 to the power of -3 meter. And you attach a weight of 25 kg to it. And after that, because of you attach this weight, it appears that this light wire here undergo an extension by 1.10 mm times 10 to the power -3 meter. So now they ask us to calculate the stress of the wire. Stress is sigma divided by take force divided by area. So what is the force that result in this stress? What is the tension that is pulling them? So you can see it's the mass over here. The mass over here, because of the gravitational pull, it will cause a pulling force on acting on this light wire. Okay, the mass, because of gravity, acts you have gravitational force pulling downwards, and that gravitational force is the weight of the mass and weight of the 25 kg weight. Why am I saying my English? 25 kg mass here hanging on the end of the light wire. This 25 kg mass here, because it has mass, there will be gravitational pull acting on this mass over here. Then this gravitational pull will also act as the tension that is stretching on this light wire over here. Okay, so this F is actually the weight of this 25 kg weight over here. So in order to find it, our weight, our force, this will be mg. Then for your area, you have the diameter. To get area is pi d over 2 square. Okay, so mass is 25 kg, 9.81 pi, diameter is 0.55 times 10 to the power of -3, divide by 2 to get the radius first, then after that we'll use square. Okay, oops, it's officially 2 hours has passed. I should hand in my paper already. It appears that I haven't finished my paper. I think all of you can forgive me, right? Because I've been doing explanation all this while. If I don't need to do any explanation, I think I should be able to finish on time. Okay. Okay, so what I get here is 1.03 times 10 to the power of 9, and the unit, take force is Newton, area is meter square, so combined together you get Newton per meter square, and that is actually also the unit for Pascal. Unit for pressure. Okay, the unit for stress is the same as unit of pressure. That's why we say we feel pressure, we also feel stress. Okay, so they share the same unit. So this is the stress in the wire. Okay, there's nothing much to explain here. So this stress here causes strain. If you want to find strain, you take the change in length divided by the original length, then you get the strain. But this is not what they're asking for. They're just asking for stress in the wire. Okay, next. The styrofoam box in figure 8 is used to keep fish cold at a picnic. Okay, so very grainy picture. So you have fish and some scallops, I think. Okay, being stored in this styrofoam box over here. The total wall area including the lid is 0.8 meters square. Means when you take the area of the top, bottom, left, right, front, back, you add them all up, you get 0.8 meters square. That's the total wall area. Okay, or there's 6 walls for this box, right? You add up the area of all 6 walls, you get 0.8 meters square. And the wall thickness is 2.0 cm. This is the thickness of the wall. If you look at this diagram over here, the thickness of this wall over here is 2 cm. Okay, they labeled 0.8 meters square already. Then probably I should label the, oops, let's label the, this one is 0.020 meter. Okay, the box is filled with ice and some fish, keeping the inner surface at 0 degrees Celsius. So this one I think is not labeled clearly. 0 is in the ice box. In the ice box is 0 degrees Celsius. Then what is the amount of heat flowing into the box every minute if the pressure outside the surface is 30 degrees Celsius? So outside is 30, inside is 0. So because outside is hot, inside is cold, heat will flow from outside the box into the box. Okay, to give you a rough idea, we can simplify this situation to a wall situation that we usually discuss in class. So imagine this is a wall, then the thickness of your wall will be 0.8 meter square. Wait, sorry, what am I doing? The thickness of the wall is 2 cm, 0.020 meter. Then the area of this wall is 0.8 meter square. Okay, instead of drawing it as 6 different walls, let's combine into one single wall that is 0.8 meters square. Then they say that the outer surface of the wall is 30 degrees Celsius, and the inner surface of the inner environment of the styrofoam box is 0 degrees Celsius. Okay, so you know that because outside is hot, inside is cold, heat will be flowing through this direction here. Okay, because heat is flowing through this direction over here, later you find the distance. This will be the distance L, then the cross-sectional area for your heat conduction. This will be your sectional area. Okay, so this is your cross-sectional area, which is 0.8 meters square. Okay, so it's important to know how does the heat flow from the hot to cold region. If you know how the heat flow, then the cross-sectional area must be perpendicular to the heat flow. Okay, your cross-sectional area must be perpendicular to the heat flow. Then your length over here should be the distance between the hot region and the cold region. The distance between it, it's L. Okay, so now we know everything already. So they ask for what? They ask for the amount of heat flowing into the box every minute. So every minute, how much heat flow into the box? That is Q for 1 minute. Okay, but now let's try to find Q over T first. That's what we are familiar with, the rate of heat flow. We find Q over T, then after that we sub in the time, it's for 1 minute, then we are able to find what's the amount of heat flow, Q. Okay, let's write it down first. Okay, Q over T is equals to negative Ka delta T over L. They didn't mention steady state, they didn't mention anything else insulated. Okay, but I assume we can use this formula. So negative K is 0.010 is given in the question. Yeah, you have to be careful. Occasionally the value just appears down there. Okay, it's not in the question itself. The total area here is 0.8 meters square. Use the SI unit. So this one is 0.8 meters square. They convert it nicely for you already. The change in temperature, you take the cold. Not change in temperature, sorry. The difference in temperature, you take the cold minus the hot. Okay, you don't have to change it to Kelvin or what. If you want to change, you have to change both to Kelvin. Or you want to keep it as degrees Celsius, you have to keep both as degrees Celsius. So that the difference in temperature will be the same. It's 30 degrees Celsius. So the distance or the length for the heat conduction to occur, it's 0.020. So from this calculation here, you get your rate of heat flow. Okay, rate of heat flow is Q over T. Okay, but if you are being efficient, you can put in a time inside here as well. Because Q over T, you put in a time, then you can find Q, right? So the time is every minute. Every minute is 1 minute. 1 minute is 60 seconds. So if you calculate everything, you'll be able to find your Q. Okay, 0 minus 30 divided by 0.0 times 0.8 times negative 0.01. Okay, so the Q over T is 12 watt right now, 12 watt, but they ask for per minute, right? They are not asking for per second. So times by 60, then you get 720. So this is 720 joule. Okay, so this one is the heat flow into the box every minute. Okay, I am actually not really sure how should we write this. Okay, let me show you another version of what I might write. Okay, since you already go over time, let's might as well just do it properly, right? Okay, so I was thinking of another thing. I was thinking already as Q over T first, then negative 0.010, 0.8, 0 minus 30. All these things is still the same, nothing to worry about. So from here, you get 12 watt first. Okay, then after that, you know that 12 watt is equivalent to joule per second. So this one is 12 joule per second. Let's convert it to minute. So you still stick it as joule, what you need to change second to minute. So 1 minute there's 60 seconds, so therefore it's 720 joule per minute. I'm not sure whether they are asking for heat flow into the box every minute. Is it like rate of heat flow, but you change the time instead of per second, you do it per minute? Or they're asking for 1 minute how much heat flow into it. Okay, if you ask me in an exam what would I leave as the answer, I'll probably leave this as the answer. Okay, but I don't think this one is really terribly wrong or what. I think based on my understanding of the question, this one is also a reasonable answer as well. Okay, but this one is per minute, this one is for 1 minute. They are the same thing. Just that this one you calculate for per minute how much heat flow, this one is for 1 minute how much heat flow. Okay, I'll leave both at here. Not sure what's the answer. Okay, as I say, I just do it the way every student would do it. Okay, next. Question 8, the last question already. The pressure and volume of a monoatomic ideal gas is this thing and this thing. And respectively, when its temperature is 273. Wow, they have been very generous. They give you almost all the information you need. Okay, so let's write it down. Pressure, of course, need to change it to Pascal. They already give you in Pascal. That's good. Volume is in liter. When they give you in liter, you have to change it into meter cube. Okay, in physics, you keep everything in meter cube. SI unit for everything. Temperature is 273 K. Kelvin is good. We don't need degrees Celsius. We want it to be in Kelvin. Okay, so every information is given to you right now. They ask you to find the number of mole. Suddenly, I feel like I'm doing chemistry over here. PV is equals to nRT. Okay, this one is very straightforward. So let's substitute P V is equals to N is what I want to find. R, use the physics R 8.31, not the 0.0207. That one you have to put in ATM liter. But this one is Pascal and meter cube. So the R is 8.31. And this one is 273. Then your number of mole will be 1.76 mole. Okay, so that's question 1. Next, they ask for the total internal energy of the gas. Total internal. I think it's just called internal. Don't need the total, because you cannot count internal energy for one gas molecule. One gas molecule doesn't have any internal energy. For internal energy, it must be for the whole system. So I think the total is a bit redundant here. U is equals to F over 2 nRT, right? Okay, now there's many ways of doing it. You know that it's also equals to F over 2 nKT. You know that it's also equals to F over 2 PV. I think for this case, probably change it to PV is the easiest choice, because you have your P and your V available already. nRT, you have more things to substitute. So let's use PV. And because we use PV, then this one, they say it's a monoatomic gas. Monoatomic gas, the degree of freedom, you have 3 for translation, 0 for rotation, vibration nothing, so it's 3. Okay, so 3 over 2, the pressure is 1.0 times 10 to the power of 5. The volume is 40 times 10 to the power of negative 3. So what I need to do now, 3 over 2 times 1.0 times 10 to the power of 5. 40. 6,000. So that's 6,000 joule for your internal energy. Okay, this one very straightforward. It's just application of formula. There's nothing much to discuss. There's no scenario here. Okay, next. Question B. An ideal gas is kept in a container in the initial state of temperature 27 degrees Celsius, volume of 30 dm cube, and a pressure of 0.2 megapascal. And the gas go through the following process. Okay, so let's write down, let's be clear what are the process. First, you go from state A, you go to state B, then you move on to state C, then move on to state D. Okay, I think the camera will be blocking it, right? Let's adjust it a little bit. Go to state B, state C, let's go to state D. Okay, so let's write down the pressure, volume, and temperature for all states. PB, PB, TB. PC, VC, TC. Not very professional. Now it's almost 15 minutes over time already. Okay, let's aim to finish it within this 2 hours 30 minutes. Okay, so I write down everything here. The pressure at state A is 0.2 megapascal. Convert it to the unit we want, that is Pascal. Volume is 30 dm cube. Convert to the unit that we want, 30 times 10 to the power negative 3 meter cube. Temperature is how much? 27. Convert it to the unit that we want, which is Kelvin. From here you'll get 29300.15. Okay, so that's state A. Let's move on to state B. From A to B, what happened is isobaric expansion. So because it's isobaric means same pressure. So same pressure, PB will be equals to PA, therefore be equals to 0.2 times 10 to the power of 6 Pascal. Okay, your volume expand to 80 dm cube. So that one will be 80 times 10 to the power negative 3 meter cube. Then your temperature here, temperature they didn't state, so you leave it blank. Okay, next from B to C is isovolumetric cooling. Because it's isovolumetric, that means same volume. Because it's same volume, your volume will be the same as VB. Oops, I think out of space here. 80 times 10 to the power of negative 3 meter cube. Okay, your pressure, they didn't give you a pressure for C, they only give you a temperature. The temperature is negative 73 plus 273.15. So that will be 200.15 Kelvin. Okay, so next from C to D, what happened is isothermal compression. Because it's isothermal, the temperature will be the same. So TD will be equals to TC, which is 200.15 K. Your volume is 60 dm cube. So 60 times 10 to the power negative 3 meter cube. And your pressure is unknown. Okay, so there's 3 unknown over here, which is the temperature at state B, pressure at state C, and pressure at state D. Those are the things that we don't know. Let's look at the question. They ask for temperature after process AB. After process AB, the temperature is TB. So this one, they're asking for TB. Next, the pressure at the end of process BC. Pressure at the end of process BC is PC. And they ask for the pressure at the end of process CD. After process CD, your pressure is PD. So you need to find these 3 things. Then they ask for work done for process CD. So you have to find work done for isothermal process. And you need to sketch the pressure against volume graph. Okay, let's move on with step 1. Okay, to find the temperature at state B, we can try to use your ideal gas equation. But I think that's a bit too elaborated. We know that we can compare between state A and state B because they have the same pressure. If they have the same pressure, then we know from chemistry, or you know from your secondary school, you know that same pressure, that means by V1 over T1 will equals to V2 over T2. I think this one is called Charles' law. If it's not called Charles' law, it's called Guy-Lussac law. I don't know which one. I can't remember whose law is this, but it's V over T, V over T. Okay, so this one you have to compare between state A and state B. So VATA is equals to VBTB. So VA is 30 times 10 to the power negative 3. Your temperature at A is 300.15. Your volume here is 80 times 10 to the power negative 3. Then from here you can find your temperature at state B. So your temperature at state B will be equals to 800.4 Kelvin. Next question. PC. To find PC is isovolumetric, so same volume. So because it's same volume, we know that P1 T1 is equals to P2 over T2 if it's same volume. Again, I don't know this is Key-Lussac law or this is Charles' law, one of it. Okay, so you have to compare between B and C. PB, TB, PC, TC. Okay, put in the value that we write up there. This one is 0.2 times 10 to the power of 6 Pascal. Temperature is what we get from question 1. 800.4. PC is what we want to find. The temperature given is 200.15. Okay, so again we calculate. Okay, from here you can get PC is equals to, let's convert it to times 10 to the power of 6. So convert it times 10 to the power of 6 is 0.05 times 10 to the power of 6 Pascal. Okay, next question, PD. To find PD, you have to compare the process between state C and state D. State C and state D is constant temperature. Constant temperature, it will be P1 V1 equals to P2 V2, right? That one I'm sure this one is Boyle's law. Okay, this one is Boyle's law. So same temperature. So same temperature, P1 V1 is equals to P2 V2. So this one will be comparing C and D. So PC VC is equals to PD VD. PC is what we get from the previous working. VC is from the question. PD is what we want to find. The volume is 60 times 10 to the power negative 3. Okay, so let's find pressure at state D. It's 0.067 times 10 to the power of 6 Pascal. So it's 0.050. Okay, so you get your TB, you get your PC and PD. You are done with question 1 and 2. Question 3 asks for the work done in process CD. Work done in process CD. Process CD here is an isothermal process. So because it's isothermal, the work done is equals to nRT ln V final over V initial. I think the information that we don't have here is the number of mole. So this nRT here, we are going to convert it into PV because we have both P and V. But the main issue is the PV for which state? For PC VC or PD VD? PC VD, PD VC, which one? Okay, we know from Boyle's law that it's the same temperature. So we want to replace it with the temperature of CD, right? So temperature of C and D are the same. So you can use either PCVC or PDVD. Either one of them will do. But you cannot do PCVD, you cannot do PDVC. Then the temperature will be a different temperature. So let's do PCVC then. So ln final volume is VD, initial volume is VC. Okay, so now substitute. 0.050 times 10 to the power of 6 volume is 80 times 10 to the power of negative 3. Your ln of Vd is 60 times 10 to the power negative 3. This one is 80 times 10 to the power negative 3. I think this will be a negative answer because the volume decrease. Volume decrease, this is work done on the system. Work done on the system, negative work done. Okay, let's try to figure this out. Yes, indeed, it's a negative answer. Remember, if it's a compression, then it should be negative work done because it's work done on the system. Okay, so negative 1151 joule. Okay, so that's your work done for process CD, no problem. Last question asks for the pressure against volume graph. Okay, let me just sketch it down here. Pressure, volume. Okay, use the unit that is most convenient for us. For here, we do everything in times 10 to the power 6, right? Times 10 to the power 6, times 10 to the power 6. So let's use our pressure unit as times 10 to the power 6 Pascal. Then for volume, is always times 10 to the power 3, times 10 to the power negative 3, times 10 to the power negative 3, times 10 to the power negative 3. So volume, we write it as times 10 to the power of negative 3 meter cube. Okay, now we are done writing out the unit. Let's try to plot the graph, sketch the graph. Before we sketch, we should roughly know what's the shape of the graph first. Okay, so let's say we start from A is over here. Isobaric expansion means by pressure is the same, so you go to the right. Pressure cannot change, right? So in your graph, your P cannot change, you move left or right. Expansion, your volume increase. Volume increase, therefore you go to the right. So this is A to B. Next, isovolumetric cooling. Your volume cannot change, so you have to be on the one vertical line because your volume cannot change, so you can only move in one vertical line. So they say cooling. Cooling means by the temperature decrease. Temperature decrease, you should move to a lower isotherm. Learn about isotherm in chemistry, right? Higher isotherm, higher temperature. Lower isotherm, lower temperature. So you need to move downwards. Okay, so B to C be here. Lastly, C to D is isothermal compression. Compression means by your volume should decrease, you should move to the left. But isothermal means by you have to follow the isotherm line. So it will be curving upward like this, I think. Okay. But they didn't say back to 80 dm cube, right? They didn't say back to the original pressure. And in fact, it's not the original pressure. So we will not connect the line back to A. Okay, you cannot connect back to A. Because A, the pressure is 0.2. But for D, the pressure is 0.067. So don't connect it back to A. It's not a cyclic process over here. Okay, so let's try to sketch everything nicely. Your volume initial is 30. Then after that, you go to 80. Okay, let's label down everything. We plot in. We put in the value in the axis first. 30 is over here, and 60 will be over here, 80 will be somewhere around here. Then your pressure, there's pressure for 0.2. Then here is 0.1, here is 0.05. Then 0.067 is probably around 0.050. Okay, so you start from 0.2 and 30, you move to 0.2 and 80. And after that, you move to 0.05, 0.05 and 80. And after that, you move following the isotherm line, move to 0.067 and 60. Okay, so now this is the shape of the graph. Let's label the state. This is A, this is B, this is C, this is D. Okay, so once we have sketched everything here, we make sure all the pressure and volume are all labeled, pressure, volume, all labeled, pressure, volume, all labeled, pressure, volume, all labeled, pressure, volume, all labeled, then we can say we are done sketching this graph over here. Okay, so I think that's the last question. Yes, indeed. So yeah, I spent about 2 hours and a half. Okay, please forgive me if I go over time for half an hour. It's because I need to explain the question as well. Okay, and I think I faced a bit of difficulty in question 2, but the rest I think is still quite doable. So I think I will check the answer at the back. If there's any correction, then I will add on a video at the back to correct my mistake. But for now, I think this is the end of my paper. Thank you very much for following me throughout these last 2 hours, 2.5 hours. Thank you very much.